Introduction: Mastering Quantum Chaos with Particle Dance-Offs. Quantum chaos is a fascinating and complex concept that has intrigued scientists and researchers for decades. It involves the study of chaotic behavior in quantum systems, where traditional laws of physics seem to break down, leading to unpredictable and erratic outcomes. Understanding quantum chaos is crucial in various scientific fields, from quantum computing to particle physics, as it provides insights into the fundamental nature of the universe. One unique approach to unraveling the mysteries of quantum chaos is through particle dance-offs. By simulating the interactions of particles in a virtual environment, researchers can observe how these particles behave in chaotic systems. This innovative method allows scientists to visualize and analyze complex quantum phenomena in a more intuitive and engaging way. The goal of using particle dance-offs in mastering quantum chaos is not only to advance scientific knowledge but also to make science and programming more accessible and enjoyable to a wider audience. Through captivating animations and interactive simulations, researchers aim to demystify the complexities of quantum physics and inspire curiosity and interest in the next generation of scientists and innovators. By combining cutting-edge technology with creative storytelling, the world of quantum chaos becomes more than just a theoretical concept. It becomes a dynamic and interactive journey of discovery and exploration. Join us as we delve into the mesmerizing realm of quantum chaos through the art of particle dance-offs. Step 1. Understanding the basics of quantum chaos. Quantum chaos is a branch of physics that deals with the study of chaotic behavior in quantum systems. Unlike classical physics, where systems follow predictable patterns, quantum chaos involves systems that exhibit sensitivity to initial conditions and non-linear dynamics. This means that small changes in the starting conditions of a quantum system can lead to vastly different outcomes, making predictions challenging and outcomes seemingly random. Chaos theory plays a crucial role in quantum mechanics by providing a framework to understand and analyze the complex behavior of quantum systems. The applications of chaos theory in quantum mechanics are vast, ranging from quantum computing and cryptography to understanding the behavior of subatomic particles in particle physics experiments. Key principles in quantum chaos include quantum entanglement and superposition. Quantum entanglement refers to the phenomenon where particles become interconnected and their states are correlated, even when separated by vast distances. Superposition, on the other hand, describes the ability of quantum systems to exist in multiple states simultaneously until measured, leading to the famous concept of Schrödinger's cat being both alive and dead at the same time. By grasping the basics of quantum chaos and its underlying principles, we can begin to unravel the mysteries of the quantum world and explore the fascinating interplay between chaos theory and quantum mechanics. Step 2. Exploring particle dance-offs as a learning tool. Particle dance-offs offer a unique and engaging way to visualize and understand the intricate interactions of particles in quantum systems. In this innovative approach, different particles are represented as dancers who compete in dance-offs to showcase the complex and often unpredictable behavior of quantum phenomena. By translating abstract quantum concepts into dynamic and interactive animations, researchers can provide a more intuitive and accessible way for learners to grasp the fundamentals of quantum physics. Through particle dance-offs, viewers can witness how particles exhibit quantum behaviors such as superposition, entanglement, and interference in a fun and engaging manner. By observing the dance moves of particles in a virtual environment, learners can gain insights into the underlying principles of quantum mechanics and appreciate the beauty and complexity of the quantum world. Animations play a crucial role in simplifying complex quantum concepts and making them more digestible for a wider audience. By visually representing quantum interactions through colorful and interactive animations, researchers can bridge the gap between theoretical physics and everyday experiences, making quantum phenomena more relatable and understandable. By embracing particle dance-offs as a learning tool, we can not only deepen our understanding of quantum physics but also inspire curiosity and excitement about the wonders of the quantum realm. Join us on a mesmerizing journey through the world of particle dance-offs and unlock the secrets of quantum behavior in a captivating and entertaining way. Step 3. Analyzing chaotic systems through dance-offs. Particle dance-offs provide a captivating way to analyze and visualize chaotic behavior in quantum systems. By simulating the interactions of particles in a dynamic and interactive environment, researchers can observe how chaotic systems unfold and explore the intricate patterns that emerge from seemingly random and unpredictable behaviors. In chaotic systems, randomness and unpredictability play a significant role in shaping the dynamics of the system. Small variations in initial conditions can lead to vastly different outcomes, making it challenging to predict the future behavior of the system. Through particle dance-offs, viewers can witness firsthand how chaotic systems evolve over time and appreciate the delicate balance between order and disorder in the quantum realm. By observing particle interactions in dance-offs, researchers can uncover underlying patterns and structures within chaotic systems. Despite the apparent randomness of chaotic behavior, there are often hidden symmetries and correlations that can be revealed through careful analysis and observation. Through the lens of particle dance-offs, researchers can gain valuable insights into the nature of chaos and explore the fascinating interplay between order and chaos in quantum systems. Join us as we delve into the mesmerizing world of chaotic systems through the art of particle dance-offs. Discover the beauty of chaos, unravel its mysteries, and witness the dance of particles as they navigate the intricate landscape of quantum dynamics. Step 4. Mastering quantum entanglement through dance-offs. In the realm of quantum physics, mastering quantum entanglement is a key to unlocking the mysteries of the quantum world. Particle dance-offs offer a unique and engaging way to simulate entangled states between particles, allowing viewers to witness the fascinating interconnectedness that defines quantum entanglement. Quantum entanglement is a phenomenon where particles become intrinsically linked, such that the state of one particle instantaneously affects the state of its entangled partner, regardless of the distance between them. This concept has profound implications for quantum computing and communication, as entangled particles can be used to transmit information securely and perform computations at speeds far beyond classical systems. Through particle dance-offs, researchers can illustrate the intricate dance of entangled particles as they move in perfect harmony, mirroring each other's actions instantaneously. By visualizing entangled particle behaviors in a dynamic and interactive format, viewers can gain a deeper understanding of the unique properties of quantum entanglement and appreciate its significance in the quantum world. By exploring quantum entanglement through the lens of particle dance-offs, we can unravel the enigmatic nature of entangled states and explore the profound implications of this phenomenon for the future of quantum technologies. Join us on a mesmerizing journey through the world of quantum entanglement and witness the captivating dance of entangled particles as they showcase the interconnectedness at the heart of quantum physics. Step 5. Applying chaos theory to programming simulations. Chaos theory offers a powerful framework for programming simulations that replicate the complex and unpredictable behavior of quantum systems. By implementing chaos theory in programming, researchers and developers can create realistic and dynamic simulations that capture the essence of quantum chaos and provide valuable insights into the behavior of chaotic systems. When it comes to programming chaotic simulations, certain programming languages excel in handling the intricate calculations and dynamic interactions required to simulate quantum systems. Languages like Python, MATLAB, and Julia are popular choices for creating chaotic simulations due to their versatility, ease of use, and robust libraries for numerical computations. To demonstrate chaotic behavior in simulated particle dance-offs, programmers can utilize coding examples that showcase the interplay between particles in a chaotic system. By incorporating algorithms that simulate quantum phenomena such as superposition, entanglement, and interference, developers can create visually stunning and interactive simulations that bring the complexities of quantum chaos to life. Through the fusion of chaos theory and programming, researchers and enthusiasts can explore the depths of quantum chaos in a virtual environment, gaining valuable insights and understanding into the intricate dynamics of chaotic systems. Join us as we delve into the world of programming simulations and unlock the secrets of quantum chaos through the art of coding and creativity. Step 6. Creating your own particle dance-off simulation. Designing and programming your own particle dance-off simulation can be a rewarding and educational experience that allows you to explore the fascinating world of quantum interactions. By following a few simple steps, you can set up your simulation environment and unleash your creativity to customize and experiment with different quantum scenarios. To begin creating your particle dance-off simulation, you will need to choose a programming language that suits your preferences and skill level. Popular languages like Python, Processing, or Unity offer versatile tools and libraries for creating interactive simulations. Once you have selected your programming environment, you can start designing the visual elements of your simulation, such as particle dancers, backgrounds, and interactive controls. Next, set up the rules and behaviors for your particle dancers to mimic quantum phenomena like superposition, entanglement, and interference. By defining the interactions between particles and incorporating chaotic elements, you can create a dynamic and engaging simulation that showcases the complexities of quantum physics. Encourage experimentation and customization in your particle dance-off simulation to explore different quantum scenarios and observe how particles behave in various chaotic systems. By tweaking parameters, adjusting initial conditions, and adding new features, you can uncover unique patterns and behaviors within your simulation, fostering a deeper understanding of quantum dynamics and chaos. Embark on your journey of creating a particle dance-off simulation and immerse yourself in the mesmerizing world of quantum interactions through the art of programming and creativity. Conclusion: Mastering quantum chaos with particle dance-offs. In conclusion, mastering quantum chaos with particle dance-offs offers a captivating and innovative approach to understanding the complexities of quantum physics. By visualizing chaotic systems through dynamic animations and interactive simulations, viewers can gain valuable insights into the behavior of particles in the quantum realm and explore the fascinating interplay between order and chaos. Understanding quantum chaos is essential for advancing scientific knowledge and unlocking the potential of quantum technologies in various fields, from quantum computing to quantum communication. By delving into the intricacies of chaotic systems, researchers can uncover hidden patterns and structures that shape the dynamics of the quantum world. I encourage viewers to continue exploring quantum physics concepts through engaging animations and simulations, as they provide a fun and accessible way to deepen your understanding of the quantum realm. By immersing yourself in the mesmerizing world of particle dance-offs, you can unravel the mysteries of quantum chaos and appreciate the beauty and complexity of quantum phenomena. As we embark on this journey of discovery and exploration, I invite you to subscribe, like, and share this video to support more science and programming content. Together, let's inspire curiosity, spark creativity, and delve into the wonders of the quantum world through the art of particle dance-offs. Thank you for joining us on this exciting adventure.